Okay, hello everyone. Welcome to my channel once again. So this is Alistair Apali alias Emma Watson. Welcome to Math is Fun channel once again. So before anything else, I would like to shout out the people around there, those who are supporting and using or maximizing this video that I have in my channel. Thank you so much for subscribing. Just continue to watch this video and you will learn a lot of things. Okay, so shout out again. SPE1 and SPE2 from Davao City National High School. Hello, students. Hello, learners. Hello, everyone who are enjoying watching this video because you don't have a choice. Just joking. Okay, so shout out for the SPE1 and 2 for the school year 2020 to 2021. And also, shout out po lang si Ma'am Emmy Dehega, math teacher sa 7 Bigonia, Lilac, Gladiola, and Magnolia. And also to Ma'am Gonzalez. Hello there, Ma'am Gonzalez. Shout out ko lang yung section niya. Granada, Marang, Manzanas, and Atis. So hello there. And also to Ma'am Holy Jane Mata. Please subscribe. Ma'am Holy Jane Mata. So, shout out ko lang yung section niya. Azucena, Sampaguita, Sunflower, and Kinakusgang Mangga. And also to Miss Dagpin, ang pinaka-sexy nga teacher sa Davao City National High School. Sexy kaayo ni siya sa iyang damgo. Just joking. Hello there. And also, i-shout out ko lang yung section niya, Section Tulip. Okay, next time around, there are more sections that will be shouting. Shouting? that wants me at them to shout out. And also to Mr. Swender. Mr. Swender, hello. Thank you for subscribing. Please continue to subscribe. Those mentioned sections, please continue to subscribe my channel and watch the video that I keep on posting in my channel because you will not just only watch the video or being entertained in the video, but also you are learning in the video, correct? Thumbs up if you agree. Sorry, I cannot see those who are doing this one because this is just a recorded rather video discussion. Okay, so so much for that. Um, we will right away go to our main focus in this video discussion, which is the lesson or the continuation of our topic, the laws of exponents. But before anything else, let me remind everyone to please subscribe my channel and please share it to your friends, especially those who are struggling in mathematics. And aside from that, please click the yellow bell button because I want you to be notified for the new videos that I will upload in my channel. I want you to be updated. And also, if you have some concerns or if you have some requests, kindly just post it on the comment section below in this video. Okay, are you ready? I hope you're all ready. And I know you are all excited to really know new things related to the laws of exponents that we just had discussed last time. Okay, so I will share now the screen. Before another thing also, please bear with me. The weather is not good as of this moment while recording this video. It's raining outside, so I'll just make my voice loud so that you can hear it clearly. Okay, our topic will be something related to, of course, laws of exponents that I mentioned. So in the objectives or the learning objectives or competencies that we have in this video discussion is you are all expected to evaluate powers that have zero exponents. So we will be focusing on the expression having zero exponents. The second one, the second objective that you are expected to in this subject, in this lesson rather, or video discussion, is to evaluate powers that have negative exponents. Again, we will focus on the zero exponents and negative exponents. Aside from that class, you are going to rewrite expressions so that exponents are positive. So remember the goal or our objective or learning objective in this video discussion. Another thing also, you are expected to apply the multiplication properties that we just mentioned in our previous topic or videos about laws of exponents or integral exponents rather. So apply the multiplication properties of exponents to problems involving zero exponents and negative exponents. So in short, our main focus in this or for today's video discussion is about how we apply and describe also, of course, the zero exponent and negative exponents to make it also, of course, for negative exponents to make it into positive exponents. So are you ready? You are ready, of course. So let us have a quick recap about what we had just started last time about the integral exponent. I mentioned about the laws of exponents last time. So we have here the product of powers property, or we call it power of a product rule, if you could still remember. It states that when you multiply expression having the same base, just copy the base and add their exponents. That's the product rule property or power product of a power rule, a power of a product rule rather. The second one is a power of a power property or power of a power rule. What does it state? It states that when an expression is raised to another exponent like this, then what will you do? Just copy the base A and multiply their exponent. So M times N. Okay, so I hope you can follow. And lastly, not lastly, power of a product rule or power of a product property. When you distribute when the two, when the expression having two variables is raised or are raised rather to a power, then you can just distribute the power in each bases, in the two bases that we have. So we have it a to the power of m times b to the power of m, distributing the exponent m. So I hope you can follow. So I'll clear this up. So that is, these are the laws or the basic laws of exponents that I mentioned last time. There's also another one, right? The quotient rule. When you divide expressions having the same base, just copy the base and subtract their exponents. And those are the laws of exponents that we just mentioned that are related or can be applied in simplifying the integral or expressions under integral exponents. Okay, having integral exponents rather. So let's start with this zero exponents. What is zero exponent? By applying the product of powers property to the following example that we find that 3 to the power of 0 times 3 to the power of 7 is equal to 3 to the power of 0 plus 7. Sorry for a while. I'll repeat. By applying the product of powers property or product of a power or power of a product, following example, we find out when 3 to the power of 0 times 3 to the power of 7, since they have the same base, just copy the base and add their exponents. So 0 plus 7 is 7, so we have it 3 to the power of 7. Again, by applying the product of powers property to the following example, we can then divide both sides of the equation by 3 to the power of 7 to determine the value of 3 to the power of 0. What does it mean, sir? So when you do, I will show it to you later. For a while. This one. What will happen? Again, as I have said a while ago, class, we can then divide both sides of the equation by 3 to the power of 7 to determine the value of 3 to the power of 0, just like this. Divide both sides by 3 to the power of 7. So cancel this one, that becomes 1. Then what is left in the left side of the equation is 3 to the power of 0, since we cancel 3 to the power of 7. And then cancel this one, that gives us 1. In short, in this case, class, we can now derive the rule or the law of the zero exponents based on the example that I give you on the screen. So again, 3 to the powers of 0 becomes 1. Why? Because we cancel 3 to the power of 7. That gives you 1. That's why 3 to the power of 0 is equal to 1. What is now your conclusion? So your conclusion now, class, under the zero property of exponents or zero exponents rule or expression that is raised to the power of 0, a non-zero number, I'll repeat, a non-zero number, this one, a non-zero number, so a non-zero number to the 0 power is 1. So a to the power of 0 is equal to 1. In short, any, I will emphasize the word, any non-zero number or base that is raised to the power of 0, the answer will always be equal to 1, where a is not equal to 0. So let's have an example. 4 to the power of 0, that gives you 1. X to the power of 0, that gives you 1. So 1 million to the power of 0, the answer will always be 1. However, when you have 0 to the power of 0, that is undefined, math error. I'll write undefined. Why undefined, sir? What's the reason? What do you think is the reason? Again, according to the rule, your base must be, or your a or the base must not be equal to 0. So if the base is 0 and raised to the power of 0, the answer is undefined. Okay? So I hope you can follow. So again, any expressions that are raised or is raised to the power of 0, the answer will always be 1. So only 1. Let's have an example. Sorry. Let's have an example. So, example number 1, we have to evaluate the following expressions. The first one, this one, -7 to the power of 0. What's your answer? Okay, for letter A, of course, since -7 is raised to the power of 0, this one, so the answer is 1. For letter B, 4 squared times 4 to the power of -2, you copy the base, right? Multiplying product rule, power of a product rule, multiplying 4 times 4, having the same base, just copy the base rather, and add the exponent. So 2 plus, since it's -2, it's just telling us 2 minus 2. That gives us 4 to the power of 0, which is equal to 1. Okay? What about this one, letter D? What about for letter D? Letter C rather. For letter C, sorry. Sorry. For letter C, I will just highlight it. For letter C, this one. So the answer, or applying the zero exponent rule, 2 to the power of 0 is 1. Then 5 cubed means 5 times 5 times 5. Multiply 5 3 times by itself. That gives you 125. So 1 times 125 is 125. The answer in letter C. What about in letter D? Okay, fraction, even if it is a fraction, as long as it is raised to the power of 0, the answer will always be 1, applying the rule. What about 0 to the power of 0? I gave it to you a while ago. The answer is undefined. Why again? Because according to the definition, your A or your base must not be equal to 0, or else it will become undefined. Okay? So I hope you will be able to understand the concept of the zero exponent rule under the integral exponents, or lessons in integral exponents rather. Okay, now let's proceed to the negative exponents. Not forget for the zero exponent, again, when we say zero exponent, any number or expressions that is raised or are raised to the power of 0 The answer will always be 1. So do not forget that 1. So we will be moving forward to the next topic, which is the negative exponents. As you can see on the screen, it's moving. Amazing, it's moving without my permission. It's fine. So let's start with this in negative exponents rule. By applying the product of powers, again, the basic rule, the power of a product rule, when we multiply expressions having the same base, what will we do? Just copy the base. A and A has common base. Copy the base A and then subtract the exponent. So n plus negative n can be considered as n minus n, which is equal to 0. So that gives us 1. Okay? So in short, in deriving this rule or to derive the law of negative exponents, we can then divide both sides of the equation by a to the power of n to determine the value of a to the power of negative n. Just like this one. You can divide this expression, okay, by a to the power of n, both sides of the equation. So you can cancel this one. That when we cancel, what's the result? Equals 1. So 1 over a to the power of n. So what will be left in the left side of the equation is a to the power of negative n, which is now equal to 1 over a to the power of n. So this is the derivation of the law for negative exponents. So this is our law for negative exponents or expressions having negative exponents. So in short class, a to the power of negative n is the reciprocal of a to the power of n. What is reciprocal? The inverse version of a to the power of negative n is the reciprocal of a to the power of n. So in short, we can write it as a to the power of negative n is now equal to 1 over a to the power of n. There is a restriction. I want you to remember the restriction class. The restriction is your a must not be equal to 0 for the reciprocal of a to the power of negative n, which is 1 over a to the power of n. So again, your a must not be equal to 0. Same in the 0 exponent rule. Okay? So I hope you can follow. Do not forget a to the power of negative n will be equal to, or is equal to rather, to 1 over a to the power of n, where a is not equal to 0. So please do not forget the rule for the negative exponents. Okay? Okay ba tayo dyan? Yes, okay. Okay pa, so all right. So let's have an example applying this rule. Okay. So in this example, let's just focus on the first example, this one. Evaluate the following expression. So the first expression we're going to evaluate is 3 to the power of negative 2. So for letter A, 3 to the power of negative 2, we can apply the rule of negative exponents since the exponents is negative 2. So we get its reciprocal. How to get the reciprocal? Just write 1 over 3 squared. So 3 squared can still be simplified into 3 times 3. That gives you 9. So the answer is 1 over 9. Okay? So 1 over 9. Another thing also, this one. Wow, this is a nice question. The second one. This one, letter B. In letter B class, that's 1 over 4 to the power of negative 3. How will you evaluate this one? Of course, you will use the concept of a negative exponent rule. So 1 over 4 to the power of negative 3, we will just get its reciprocal of this, which is 4 over 3 by making its exponent positive. So 4 cubed now becomes 64. Why 64? It's like multiplying 4 by itself 3 times. 4 times 4 times 4. That gives you 64. So brilliant, right? Now, we write the following. This one, we'll go over now with this. Rewrite the following expressions using positive exponents. So let's have letter A, 5x to the power of negative 4. As you can see, only what? What have you observed in letter A? In letter A class, as you can notice, only x has a negative exponent. So what will be applied here is, or next, we can have now 5 times get the reciprocal of x to the power of negative 4, which is 1 over x to the power of 4. So 5 times 1, that gives you 5. Then there is 1 here below 5, the denominator of 5. So 1 times x to the power of 4 is x to the power of 4. So our answer now is 5 over x to the power of 4. I hope you got it. Okay? So that's how you do it. What about for letter B? Wow, letter B is so amazing. Why amazing, sir? Because, it has two negative exponents, both numerator and denominator. Actually, the solution is somehow complicated, but it's easy. There is a shortcut in here. So a to the power of negative 3 and b to the power of negative 5. Of course, get the reciprocal of a to the power of negative 3 in your numerator, which is 1 over a cube. And also you can get also the reciprocal of your denominator, which is b to the power of negative 5, that gives you b to the power of 5. Then multiply it, b to the power of 5 times 1, that gives you 5, b to the power of 5. And then there is 1 in the denominator of b to the power of 5, multiply it to the denominator of 2a cube, rather, that gives you a cube. So the answer now is b to the power of 5 over a cube. Okay, sir, what's the shortcut in here? Actually, in letter B, since both of them have opposite, or what I mean negative exponents, you can just write them in an opposite way by just interchanging them. B to the power of 5 over a cube. That's it. Okay? So just be creative in thinking or applying the laws of exponents. Just too easy, right? Very easy, sir. Yes, chicken, of course. Now, I want you to try this. Evaluate the following expressions. Sorry. I'll just show it to you. You try it. I want you to give the answer. Perhaps you can just send the answer below in the comment section in this below the video, or this video below in this video rather. So you can just post your answer that try it. Okay, because we don't have enough time. Oh, there is an answer. I'll just. Okay, so negative 3 to the power of 0. Okay, to simplify letter A, that gives you negative 1. Why negative 1, sir? Only 3 over 5 is raised to the power of 0, so that is equal to 1. Then multiply it by negative, so that gives you negative 1. Okay, that's letter A. For letter B, how did we get 24? So this one, get the reciprocal of this. Again, just make it positive, the exponent, so that gives us 2 cubed. So simplify 2 cubed, that gives you 8. Why 8, sir? 2 times 2 times 2. That's 8. Times 3, we get 24. Now for letter C class, 9 to the power of negative 4 and 9 to the power of 7. Applying the product rule, just copy the base 9 and then add the exponent, negative 4 plus 7. Since they have opposite signs, so we are going to subtract them. 7 minus 4 is 3. That's why we have it 9 to the power of 3. 9 to the power of 3 is like 9 times 9 times 9. That gives you 243. Amazing, right? And for letter D, applying the power of a power rule first. So when an expression is raised to another power, just multiply it 2 times negative 2, the power, and copy the base. Then we have it negative 4 as its exponent. So 4 to the power of negative 4 will be, oh, the answer is wrong. Oh, so sad. So the answer must be 1 over 256. This is wrong. Why 256, sir? Because you will still apply the negative exponent rule for negative 4. So that gives you 1 over 4 to the power of 4. Since negative exponent is not accepted, this is the reason why I introduced the negative exponent. Make it positive. How? Get its reciprocal. So 1 over 4 to the power of 4 will give us 1 over 256. Why 256, sir? 4 times 4 times 4 times 4. That's it. 256, not 4 times 4. Okay? So for letter E, how did we solve it? So of course, again, get the reciprocal, applying the negative exponent. How? Get the reciprocal by making its exponent negative to as positive exponent, as you can see. And also, for 12 to the power of 0, we will apply the 0 exponent rule, which is equal to 1. Any number that is raised to the power of 0 or variable that is raised to the power of 0, the answer will be 1. Okay, so 3 squared, simplify 3 squared. 3 times 3 is 9. Times 1, that gives us 9. Okay, so chicken, very easy class. I hope you got it. So these are the applications of the zero exponent rule and negative exponent rule. So I hope you will be able to remember these two laws under the integral exponents lesson. Okay? So I hope you are learning so far about how to apply the zero exponent rule and how to apply the negative exponent rule in simplifying expressions or polynomial expressions rather, or any algebraic expressions. Okay? So I hope you can follow. Thank you for listening. And for our next video, I want you to really read more about uh, application of the laws of exponents. That is something like so exciting. So see you next time around. Thank you for listening, class. We will just end up here. Do not forget the two laws that I introduced to you in this video, the negative and zero exponents rule. And if you enjoy watching this video or if you learn something in this video, I want you to share it with your friends again, especially those who are struggling in mathematics. At least you can help them improve their performance in math. So I'm happy to share the blessings or to impart my knowledge with you all. And thank you to all subscribers, especially to those who are not yet subscribing my channel. I want you to click and subscribe the my channel, Alistair Apale. And also just click the yellow bell button. At least you will be notified once there is a new video that will be uploaded in my channel. And also to all my subscribers and my fans, shout out. Thank you so much for supporting my video, and also to the students who are keep on watching my video. You are not doing something like useless thing, because you are making yourself more productive because you are learning and improving your skills in mathematics. So hope to see you soon. Hope to see you in my next video. Thank you so much. Have a nice day, everyone. Subscribe my channel once again.